Let's talk about series. Before we talk about series, I need to go over once again what is a sequence. So for a sequence, what is a sequence? The easiest definition I can give you is a list of values or a list of numbers separated by comma, and then they follow a certain pattern. So following certain pattern, following a certain pattern. Sequence, we use AN. So AN equals to, you have to tell me what that pattern is. And then for series, then that will be the sum of all the numbers. So sum of a sequence, And then we use this sigma. This is a Greek letter, sigma. Sigma in math means the sum of AN, the sum of all the numbers in a sequence. And then we can have an infinite series or a finite series. So for infinite series, I can write something like we have a summation. I can do I goes from 1 to infinity, AI. So what is this? What does that mean? That means when I is equals to 1, we have the first term. When I is equals to 2, we have the second term. I equals to 3, we have the third term. So this one is really like A1 plus A2 plus A3, and then you keep on adding. And then you will reach to the nth term, but you have to keep on adding because with this one will stop at infinity. So we are adding up infinitely many terms, and then we call this infinite series. And then other than that, we can find the sum of infinitely many terms. You can find the sum of infinitely many terms. And then that leads me to another question. You are adding up infinitely many numbers, right? So most people will think that, all right, you are adding up infinitely many numbers, and then the sum must be very large, so infinity. I will say, yes, you can think about that way. Adding up so many numbers, yes, you will get a sum that is very big, but not always infinity. So sometimes that equals to infinity, sometimes that equals to something else, like equals to a real number, and then we can have a finite series. So this is I goes from 1 to n. So we are adding up the sum of n terms. So that is A1, or not A1, that is AI. So this is when I equals to 1, I equals to 2, I equals to 3, and then we keep on adding, and then we stop at the nth term. So this is the sum of n terms. N is a real number. So since that is countable, we call this a finite series. All right, and then other keywords, we can have sequence of partial sums. So sequence of partial sums. For examples, sum of one term, sum of two terms, that is A1 plus A2, and then sum of three terms, and that will be A1 plus A2 plus A3. We can keep writing. So sum of three terms, so that is A1 plus A2 plus A3, and then the sum of n terms, then that will be A1 plus A2 plus A3, and then we keep on adding, add until we reach to the nth term. So this is, we call this the nth partial sum. Okay, so now back to that topic. So we are adding up infinitely many terms. Is the sum always infinity? The answer is no. So when the sum equals to infinity, most people think that way. We say the series diverges. Pay attention to this word, diverges. If the sum, if the sum, oh, sorry, this is not an, this is supposed to be Sn. The partial sum in a curly bracket, the partial sum diverges. Diverges. Okay, let's write diverges. Wrong color. Okay, trying to match the blue. Diverges. and then that one will be the sum is equals to infinity. The sum is equals to infinity. Let me give you an example. So how about this? I am writing a basic series. So this is a summation. Let's don't use I, let's use n. N goes from 1 to infinity. I have 4 to the n power. That is 4 to the first, plus 4 to the second, plus 4 to the third. And then you keep on adding. You will be adding 4 to the 200th power. And then you keep on adding, you will reach to 4 to the 10,000 power, and then you will keep on adding, and then you will add 4 to the infinity power. So these terms are big enough. When you add them, that will just give you an infinity. So I am going to make an observation right there. So this term, base 4 raised to a very high power. So as n approaches to infinity, we will say these terms is equals to infinity, and then the sum of infinity, you are adding up a huge value, many of them, then you will just get a infinity. And then we will say this, the limit as n approaches to infinity, 4 to the nth power is equals to infinity, and then we say the series diverges. The series diverges. What about converges? Okay, let's do a converges. Then let me switch to another blue. Let's use this blue. And then I can say the series converges. So the series converges if the partial sum converges to S. And then the sum is a real number, so equals to 100, 1,000, 564, 59, something like that. And then we have a summation. So all you need to do is we will just make a minor change. N starts at 1 to infinity. I will also use 4 to the n, but I will do 1 over 4 to the n. So that is 1 over 4 to the first, plus 1 over 4 to the second, plus 1 over 4 to the third, and then we keep on adding, we will have 1 to the 100 power, right? And then keep on adding, you will add like 4 to the 1,000 power, and then you keep on adding, you will add 1 over 4 to the infinity power. So 4 to the 50 power, 4 to the 100 power, that is a very large quantity. And then you have 1 divided by a very large quantity. Think about it. You have 1 divided by, let's say, 8 billion. What is the quotient? The quotient is not exactly 0, but the quotient is very close to 0. 1 divided by a large quantity. Imagine you have 1 pizza. You cut it up into maybe 100 million pieces. How big do you get for each piece? It's not 0, but it's so small. It's close to 0, but not exactly 0. And then we can make an observation like this. So for these terms, when n is large, so we say as n approaches to infinity, these terms are close to 0. The sum is determined by the first few terms. The sum is determined by the first few terms. First few terms when n is small. So the sum is really determined by the first couple fractions. And then what can we say at this in this example? So we can say limit as n approaches to infinity, 1 over 4 to the n. That is 1 over 4 to the infinity. That is 1 over a very large power. This is near 0. So that means we say the series converges. All right, so we have an example, the series diverges versus the series converges. So the series diverges, once again, when n approaches to infinity. So this one, they are very large value. When you add them up, the sum is infinity. So the sum is equals to infinity. When n approaches to infinity, these numbers are so big, so you are adding up a bunch of big values, therefore the sum is infinity. And then versus, you have 1 over 4 to the n, when n is very large, you are adding up a bunch of zeros. Not exactly zeros, but the value are so close to 0. And then therefore, the sum is really determined by the first couple fractions. And then we say that when n approaches to infinity, those terms are nearly 0. So the sum is really determined by the first couple fractions. We are not trying to find out what the sum equals to at this time. What we are saying is the series converges. Okay, so in the second example, the series converges versus the series diverges, but we are not finding what the sum equal to at this point. So this video, I would say that is the end of this video. So we introduce what a series is, partial sums, series converges, series diverges, and then in the next video, I will explain the basic of geometric series. Okay, see you there.